These are, what is this? Solving a value mixture problem using a linear equation. This strategy that I'm going to show you about making a table to help you find your equation to use to solve the problem, you can use the same strategy for a lot of the word problems in algebra, whether they're these value problems where there's things that cost different amount of monies, or the distance, rate, time problems where you've got trains going in two different directions or the same direction, or sometimes there'll be a boat floating against the current or floating with the current, and sometimes it'll be a percent solution problem. And all of these problems are a million times easier if you make a table to organize the information and then fill out the table based on the information the problem gives you. And then you can find your equation to solve. So I'm going to walk through a couple of these and show you how to set up a table to solve them. At the City Museum, child admission is $5.30 and adult admission is $8.70. On Saturday, 148 tickets were sold for a total sales of $961.20. How many child tickets were sold that day? All right, so we're going to make a table to figure out this problem. This is about a cost per ticket, a number of tickets, and a total cost. So our table is going to be, at the top, we're going to make columns. The number, oopsie, might help if I could write. Okay. The number of tickets times the cost per ticket equals the total cost. So just as an example, let's say there were 10 child tickets sold. That would be the number of tickets. Each child ticket costs $5.30. That would be the cost per ticket. And we could multiply across 10 times $5.30 to find out the total cost of child tickets, which would be $53. Okay, so these are our columns that we're going to fill in. The number of tickets, the cost per ticket, and then the total cost. And then we have two different types of tickets. We've got the child tickets and the adult tickets. So our rows are going to be child and adult. All right. So looking back at the problem, it always helps to find the question in the problem. How many child tickets were sold that day? How many child tickets? How many tickets? That is this column, the number of tickets. Since that's the question, that generally tells us that our variable is going to be in this column. Because that's the unknown, and that's what we're trying to find. The question is the clue to what the unknown is. So how many child tickets were sold that day? Well, we don't know. So let's make that X, the number of child tickets sold. We know the cost per ticket of the child tickets is $5.30. We know the cost per ticket of the adult tickets. That's $8.70. We do not know how many adult tickets there were sold. We know 148 tickets were sold altogether. X of them were child tickets. So whatever was left over was adult tickets. So whenever you have a total of, oops, not 149, 148. Let me erase that. Okay, so there's a total of 148. X of them were children tickets, so the adult tickets were 148 minus X. Say there were 20 child tickets, there would be 148 minus 20, or 128 adult tickets. So it's X and 148 minus X. Okay, so to fill in the total cost for the child tickets, we multiply across X times 5.30. Or we can write that as 5.30X. The total cost of adult tickets will be 148 minus X. this whole quantity, so let's put it in parentheses, times 8.70. So I'll write that as 8.7 times, because 8.7 is the same as 8.70, times 148 minus x. And finally, the total cost altogether of all the tickets is given in the problem, $961.20. That's the total. Okay. Now, if we look at our columns here, one of our equation will always end up coming out of one of the columns. And in this case, you can see that we have a great equation here. If we add the total cost of the child tickets to the total cost of the adult tickets, it will equal the total cost. So our equation comes right from that column. 5.3x plus 8.7 times 148 minus x equals 961.20. Okay, so let's simplify the left side. So 5.3x plus 8.7 times 148, we're gonna distribute to get rid of the parentheses. That equals 1287.6 minus 8.7 times x equals 961.20. Now we can combine like terms on the left side. 5.3x minus 8.7x equals negative 3.4x plus 1287.6 equals 961.20. Now we're going to subtract 1287.6 from both sides. So 961.20 minus 1287.6 equals negative 326.4. So negative 3.4x equals negative 326.4. Now we can divide 326.4 negative by negative 3.4, and we get x equals 96. Okay, and then we can look back at our table to remind us what x stands for. X stands for the number of child tickets. And the problem asks how many child tickets were sold that day. Well, we found the answer. The answer is 96 child tickets were sold that day. So let's put it in. Okay, good job. Let's try another one. A web music store offers two versions of a popular song. The size of the standard version is 2.7 megabytes, and the size of the high-quality version is 4.6 megabytes. Yesterday, the high-quality version was downloaded 3 times as often as the standard version. The total downloaded for the two versions was 4,785 megabytes. How many downloads of the standard version were there? Okay, so we're going to make a table again. This time we're going to have the number of files download, or the number of downloads, times the size of each download, equals the total size. So if we have a 2.7 megabyte small file, if 10 of them were downloaded, we would do 10 downloads times 2.7 megabytes equals 27 megabytes altogether. So that is our formula, and it makes sense. And then we're going to have our, for our rows, we're going to have our standard version and the high quality version. I'll just put HQ for that. How many downloads were there? So that's going to be our unknown. How many downloads are this column here, the number of downloads, is going to have our variable. Oops, let me try to erase this. All right. How many downloads? We don't know, but what do we know about that? We know that the high quality version was downloaded 3 times as often as the standard version. So we're going to put X for our unknown, how many downloads of the standard version, X. And the high quality version number of downloads is going to be 3 times as many, so 3X. We know the size of each download. For the standard version, it's 2.7. And for the high quality version, it's 4.6. So we can multiply across to fill in the last column. 2.7 times X is the total size downloaded of the standard. And 4.6 times 3X is the total size for the high quality. And the total size downloaded for the 2 versions was 4,785 megabytes. And that is the total. So just like in the last column, or in the last problem, we're going to get our equation from this column. The total size of the standard plus the total size of the high quality equals the total. That's going to be our equation. So 2.7x plus 4.6 times 3x equals 4,785. So we're going to simplify by multiplying here. 4.6 times 3 is 13.8. So we have 2.7x plus 13.8x equals 4,785. 13.8 plus 2.7 is 16.5. So 16.5x equals 4,785. And then we need to divide both sides by 16.5. And we get 290 for x. All right. Looking back at our table, we see that x stands for the number of standard downloads. There were 290 standard downloads. That's what the question is asking for, 290. Yay.